Hey everybody, and welcome to another great Behind the Divs. Today we're going to be talking with the team behind the new Chrome experiment, Roll It. So with that, I want to introduce you guys to two of the engineers. Sean, why don't you go ahead and introduce yourself?
Hey everybody, my name is Sean Klassen. I am one of the founders of a company called Legwork, and we're based out of Denver, Colorado. And the Google Creative Lab came to us to help them realize this new experiment. They wanted to show off some technology with WebSockets and syncing your mobile device with your computer.
Cool. And Justin, do you want to introduce yourself?
Absolutely. I'm Justin Gitlin, also in Denver, Colorado. I'm the one of the co-founders and partners in a development shop called ModeSet. And we've worked with Sean at Legwork before, and we all used to work at a company together back in the day, so I've got a great relationship with them. And so we did most of the front-end development.
Cool. So actually, that's a good question to start off with. You guys are sort of two different agencies. How did you split the work between the two of you guys?
I guess, originally the Creative Lab came to us and they're like, hey, we have been prototyping with this new technology. We want to make a game with it. What do you guys have for ideas? And we came up with a bunch of different things. I remember at one time we were talking about making almost like a Guitar Hero type of thing where you'd like rock out against someone. Mm-hmm. And eventually settled on where we did with this game. And we brought in Justin, like he was saying, we've worked together on a bunch of projects, and he's awesome at mobile development and just a great developer in general. And he helped us make this thing a reality. It was really pretty agile environment. We had, some initial features and user stories set up, and then just kind of kept iterating on the design and the dev really all the way till the end and the launch, and we ran out of time.
Yeah, that's often how it works. It's sort of like really crazy right up until the end, and then once you hit the end, you're like, this is actually really good. We're really impressed with this. So
yeah, and it's always nerve-wracking too, because you've been so buried in it, and you don't know how it's going to be received.
Yeah, absolutely. And I want to mention to the folks who are watching live right now that if you have questions that you want to ask of either Justin or Sean, you can post those to Google Moderator. The link is there on screen somewhere that way, I think. But you can post those there. We'll be taking those as we go throughout our Hangout today. But I want to ask you guys a little bit about the workflow, because working between two agencies and the Google Creative Labs team must have been kind of interesting. And I know that at Google I/O this year, one of the most popular sessions from the Chrome side was about the modern mobile workflow. What did your mobile workflow look like?
So the workflow from my end, from the development side on the front end, was building all of the code, or writing all of the code in a Ruby on Rails environment. And with that, you get all the benefits of the Rails asset pipeline, which concatenates all your files, compresses them, transcompiles any Coffeescript or Sass, HAML, using sprockets and whatever other machineries in the asset pipeline to make that a really seamless process. I mentioned it. Almost all of the custom code for this game was written in Coffeescript.
Right.
And we found that to be we end up with less code, cleaner code than writing pure JavaScript. So that's something that we at ModeSet generally will write 99% of the time. It depends. If we're writing something under 500 lines of code and that's the entire project, or a quick prototype or something, we might just write some raw JavaScript. But we've really come to love the things that you gain out of Coffeescript, especially for this project, which was quite a bit of code, many thousands of lines of custom code on top of all of the third-party libraries that we used. And built in a really object-oriented way, we found that it really helps you organize and end up with much cleaner and less code at the end of the project.
Huh, that's interesting. One of the questions actually in our moderator queue is about why you chose Coffeescript, which you kind of addressed. But is it something you'd recommend other folks use?
Definitely. I mean, so obviously you have to they call it transcompiling Coffeescript to JavaScript. So there is one step before your Coffeescript is ready to be interpreted by the browser. Mm-hmm. And in our environment, the Ruby on Rails environment, it's really easy to set that up and make it completely transparent. If you don't have a Ruby on Rails environment or something like that that's going to do it automatically for you, as you're writing and refreshing the page and hitting your server, mm-hmm. I've found a lot of people are using a front-end compilation tool called Grunt.
Right.
That seems to be a really popular one, and I've started playing with that, and it's really nice. So I'd say if you're not using any sort of server backing up your code, Grunt's a great way to go to compile and do all of the same things pretty seamlessly as well.
We've used that on some other projects here ourselves when we don't want to build any kind of backend system or don't have access to do that for whatever reason.
Cool.
Sure, because not every project is going to have a backend.
Right.
We've had projects where, we just upload a bunch of files to an Apache server and that's it. So I think in that case, something like Grunt's a great option. In our case, we did end up compiling the entire site down to static files, and we used the Ruby on Rails helpers to do that for us. So we just wrote a little bit of Ruby to take our dynamic assets and translate those into a static file system.
Okay. So what other tools were you using for your build process?
On a higher level, because Google Creative Labs is in New York. We're both in Denver. So we needed just some communication tools that were pretty important. We use Google Hangouts almost every day. And then we use Pivotal Tracker to track all the features that we were working on and prioritize them.
Okay.
And, that was probably one of the biggest, most important tools for us.
Were you using that for bug tracking, or what were you using that for?
We used it for bug tracking, and then we also used it just to know what was next in our to-do list, if there's revisions or how difficult things were going to be, like if we were going to hit our milestones. And we put design items, right along.
Okay, all the design and tasks items were in there as well. Cool.
That's a good way to sort of, have some conversation going back and forth about, bugs or features, creating new user stories if somebody has a brand new feature they want to add into the app. It's something that we track all that right there and prioritize by sort of ordering the list of stories in Tracker. So it's just a nice project management tool.
And that's Pivotal Tracker, you said?
Yep.
All right, cool. So let's take one of the questions from the folks who are watching live. And Manuel wants to know, how is it possible to send the data from the gyroscope so fast through the web, including all the coding and encoding that makes such a game possible?
So the key technology there is Websockets. So if you're not familiar with Websockets, it's a lower level, faster protocol rather than using HTTP requests. Mm-hmm. It creates more of a direct connection between your machine, a server, and then another machine. Or any number of machines, but in our case, for Roll it was your mobile device and your laptop, and all those messages are going through a server somewhere else, which I think a lot of people are surprised at how quickly you can get those messages transmitting.
Yep.
We were sending about 15 to 20 messages a second during certain parts of the game, specifically during gameplay for some of the ambient elements to have a little tilt based on the accelerometer data coming in. As well as on the menu screens, the entire menu sort of tilts back and forth, and you get a little ball rolling across the screen to show what your menu selection is. And it's in our case, we're only sending a really small amount of data for that, pretty much just the tilt, angle.
Right. So that effectively, when in the document or in the case study that you guys wrote, it looks like that's only, maybe 50 bytes or so to send the tilt. Is that right?
Yeah, something really tiny like that. It's a really small JSON object that gets transmitted over WebSockets and picked up on the other device. So, yeah, I mean, obviously, the smaller you can keep that data transmitting, the quicker it's going to go, and the chance of losing messages along the way due to latency would be decreased. So, obviously, in our case, you want to make that as small as you can.
Mm-hmm.
I think that was something that we tested a lot up front, even before we got into the interface design and stuff, because we didn't want to set up the situations, or we at least wanted to minimize the situations where there would be that lag time, and we wanted to know how far we could push that with it still feeling like a nice experience.
Yeah, cool. Well, why don't we take another one of the questions from there? Are the techniques going to be? Are there going to be more practical uses for this modern technique? Do you think?
I would think so. I mean, Google Creative Labs is awesome at coming up with new ways to push the technology that's coming out in Chrome and just on the web in general. And hopefully, if we all did our jobs right, this will inspire lots of people to come up with new practical ways to use this technology. Like, games obviously really fun, especially if it was for us to work on, but I think there's a lot that could be done with this for sure.
Cool. Yeah, go ahead.
Gaming's a great example. But yeah, I think there are plenty of opportunities to create new gestures and create new interactions with the web.
Mm-hmm.
And, yeah, it's up to us to come up with those, right?
Yeah, and that's one of the cool things about Chrome experiments is they are designed to make it really easy to show developers what is possible and what's sort of available on the web. I'm kind of curious about one of the comments in the case study that you guys wrote, and you talked about the development tools becoming more mature for the web. And you talked about just some of them that you used, like Cinema 4D and Blender. What were some of the other tools that you liked, and what was the Chrome developer? What was the part of the Chrome developer tools that you found most useful?
I can speak to some of the other applications. We still used Photoshop to do the interface stuff, which I know some people think is old school, probably, but it still is the best method for us. And then I think all the developers these days are using Sublime Text to edit their code in, and then when you get into the console and stuff in Chrome, that's obviously critical. Justin probably can speak better to that than I can.
Yeah, I think the biggest thing the biggest tool in the developer tools inside of Chrome was the timeline with watching memory usage.
Okay.
Just to make sure that our memory heap didn't keep growing beyond a reasonable boundary. So that helped just kind of track down memory leaks along the way. I think when you're running at 60 frames a second inside of a video game environment, you have to be really careful about instantiating new objects and rather reusing objects whenever possible and resetting values rather than creating new objects along the way. So I think the memory usage tool is really helpful with that. Obviously, the network panel will show you any requests coming down, so that was helpful in kind of reducing the overall number of requests. So one thing that we did to sort of minimize the amount of requests was Base64 encoding everything that we possibly could that was a reasonable size to Base64 encode.
Yep.
So any image under around 10K in size, we'd Base64 encode, put that directly into the CSS or inline in the HTML as an image source attribute. Mm-hmm. As well, you can use Base64 encoded images as 3JS textures. So 3JS was the 3D library that we used to create the 3D environment. As well, we Base64 encoded the fonts. So pretty much anything that was going to be an external request that was small enough, we encoded to be in line with the CSS or the JavaScript.
Now, I remember reading in the case study that you said, in particular with the Base64 encoding the fonts, did you Base64 encode both the different types of fonts? And if so, do all browsers download both of those, or do you do some smarts to say, oh, this browser supports this, so I'm going to send only this type. This browser supports this, so that you reduce the size of the download?
Yeah, all of the modern browsers should download them fine at this point.
Yep.
And we did have to do a little rearranging. I found one little bug in which case a certain browser needed the SVG font listed in front of the WAF font to draw into the canvas context correctly. But generally, yeah, we used an SVG font and a WAF font, and that seemed to be enough to cover all the modern browsers.
Cool. Well, why don't we take another question from our moderator queue? And again, the link, if you want to submit your own questions, is there on the page. But did you have any challenges syncing the devices and the screens? And this is from Fred in London.
I think the Google team had that theoretically working when they came to us, and there was a little bit of a challenge, but that was not one of the harder parts of the development at all.
That system was built not by us. It was the development team that also built the back end for the Racer experiment and the Jam with Chrome experiment, and they've sort of gotten it down to a science at this point. Mm-hmm. And that all works over WebSockets once the connection is established, but there is a bit of upfront process that has to happen between the two devices. So, there's the code that you get when you start a game that you use to connect the two devices together, and there's a bit of back-end work that goes into generating that code, the desktop telling the back-end, okay, we're using this code, so give me a server, and once you get that server, that's sort of stored on the back-end to create the WebSocket connection.
Yep.
And then on the mobile end, you enter your code, and the back-end recognizes that code, sends you back that server, and that's how both ends of how both devices end up with the same WebSocket server. So that upfront process, there was certainly a bit of back-end work that went into it, but implementing it from the front end was pretty easy with the API that they had set up.
Oh, nice. So it was just simply an API library that you could call into and just be like, hey, I want to go do this, and it just worked relatively easily for you?
Because the back-end developers were great at what they did, definitely, and that's all built on with the Go language on Google's App Engine and Compute Engine. So there's a whole series of technologies that will create like a private WebSocket server for the two machines for a game, and does a lot of load balancing up front. And one interesting piece of that equation was that on the front end, we would receive a list of up to three different WebSocket servers, and we would ping each one to try to find the closest and fastest WebSocket server to the user. So there was some optimization there to make for the quickest experience on the front end.
Right. So actually, that leads into another interesting and I think pretty important question for mobile and just for the web today in general, and that's like Perf Matters, right? Like performance is really important. How did you guys think about some of the performance throughout, or how did you think about performance throughout the entire building of this experience?
I'd say that was really challenging because we were using some things that we hadn't necessarily developed any kind of major projects with before, and luckily we didn't have to support every browser out there for this, because some of the technologies don't work. But it was something that we had to balance with just building the actual features themselves. So, even post-launch, we've noticed some bugs and stuff that we fixed, or just ways to improve performance. But there's always room to get better at that, for sure.
Yeah, absolutely.
Yep. And I think some of the things that I ran into that were really big hits on performance were in 3JS, the 3D library. The more you have loaded into that 3D environment, the slower it's going to go. So in the 3D world, the lower poly you can make your models, the faster it's going to perform. So having fewer polygons in your 3D meshes. So that's something we went back and forth a lot between the code end and Sean's team, who were building the 3D models for the skee ball lane and any other 3D models that were in the game. So there was definitely a bit of figuring out through their tools like Cinema 4D and Blender on how to reduce the polygon count before they exported those models and sent them over to me to drop into the 3JS scene.
Yeah.
Similarly, the physics library that we were using, PhysiJS, which is sort of a wrapper around a 3D physics library that is really easy to drop into a 3JS scene. The more walls that you create that are physics enabled, the more collision detection has to happen. So,
right.
The less processing per frame in the game that we could execute, the better. Yeah. So we did some manual sort of creation of the physics scene that's invisible to the user, but is like the 3D models that you see in the game are just a facade over some 3D physics objects that were created manually in JavaScript.
Now, do you do any dynamic changing of the amount of processing that's done depending on, how fast the user's computer is or what device they're running from or anything like that?
We started to.
Okay.
So I got into something along those lines towards the end of the project when some older machines weren't running quite as well, but it turns out that some of the aspects of 3JS can't really be changed on the fly, and that's kind of what I was checking. Like if you were running at 20 frames a second versus 60 frames a second, I was trying to drop certain lighting or shadowing, but it turns out that's pretty hard to achieve without sort of rebuilding the entire scene without those features. Mm-hmm. And that's due to 3JS being really good at optimizing lighting and building your shaders once and storing those on the video card, and that's why 3JS runs so quickly, but it also means that changing certain things on the fly is going to be really tough.
Yeah, that makes sense.
And there's, WebGL was pretty interesting to work with too, because we had to try and detect a bunch of different stuff. Like some computers will allow aliasing, some don't, and there's a software component to it to make it work, but there's also a hardware component. Mm-hmm. And we can tell someone to upgrade their software, but we can't get them to upgrade their hardware. So.
Yeah, that's a little bit harder. Yeah. Why don't we take one of the next questions in the moderator queue? Manuel again wants to know, why didn't Chrome need any special permissions to use the gyroscope without having to root the device or anything like that?
I guess that's I guess there are certain things that are clearly sort of violations of somebody's privacy. If a website's going to access your camera without asking, that's that shouldn't be allowed. I think most people would agree with that. And we did work with the Google Creative Lab team to make sure that we were not sending any sensitive user data over the connections, because I think Google clearly with that process that we had to go through to sort of like outline every little bit of information we're sending from machine to machine, that there's clearly a lot of sensitivity to people's privacy, which I definitely appreciate. And I think you can't really glean anything from the accelerometer about where someone is or necessarily what they're doing, or you can't really be creepy with that data.
Yeah, no, that's very true. And one of the cool things is that the accelerometer, the device motion, device orientation stuff is all part of the standard HTML5 spec. So that's available to any developer who wants to build for the web.
Yeah, and I think Androids and iPhones, pretty much all smartphones, allow you access to that within the browser now, if at least if the software is current. So
yeah, actually, that's a good question. Was there? Did you face any problems in dealing with the experiment or with anything like that in dealing with the device orientation and device motion stuff?
Yeah, there was definitely challenges. I think the biggest thing was doing our best to normalize the data to one solution that worked across everything that supported those objects. Really is, some phones are better than others, and but I think we came up with a pretty good way to make it work across everything, pretty much the same.
Awesome. All right.
Yeah, I think just to follow up on that, I think like certain phones will have a faster rate at which the accelerometer updates come in, or the accelerometer event is fired on the window.
Yep.
So to pick those up at different intervals, and we implemented some time stamping along with each update to sort of normalize them across across devices. So maybe a device that's running slower than another device will hopefully feel pretty much the same. And we definitely went through a lot of iterations of how the swing, like as you swing your phone to perform the roll gesture, we went through a lot of iterations where, we would think it felt good, but then we'd hand it to somebody else to beta test, and they just wouldn't be able to do it. So there was a lot of sort of back and forth on watching how people picked up a phone and swung it, and sort of adjusting based on what we saw. It's easy as somebody who's developing something like this to get to a point where you think, oh, this is great, it works, and then you hand it to someone else and they just can't figure it out. So there was definitely a lot in terms of making the roll gestures feel right.
Cool. So another question. This one actually comes from Paul Kinlan, one of the guys on my team who's based in London. He wanted to know if there were any features that don't exist as part of the open web platform that you guys would have liked to have had, that would have been useful, that would have made building this experiment easier.
I don't know. I never even thought about that, because the job from the start was to think, what can we do with this technology? But I guess maybe you're somewhat limited in, the connection of the speed of your connections, and how fast things return from the gyroscope and accelerometers and stuff. But I don't know. I think it was pretty good.
Cool.
Yeah, I guess one thing that I could think of is, given that the game is based so much on the WebSocket protocol, and that does require obviously going out to a remote server and then coming back into your house or office or wherever you're playing. There are certain certain corporate offices or cell providers that block WebSockets connections. So that was a pretty big challenge that we ran into, and especially testing that was really tough. Somebody testing it may have been in an office that was blocking WebSockets, but we didn't have access as developers to get in there and actually see what type of errors were being thrown or how that WebSocket connection was closing automatically. So we ran into some pretty tough issues along those lines. So I mean, one thing that maybe would have been cool would be to not have to hit a remote server to have your WebSocket connection established.
Yep.
Or maybe some way of syncing two devices and creating that connection without having to hit a server. I mean, that could be cool.
Yeah. In fact, that is coming. That's coming as part of the new WebRTC APIs, and they're going to allow peer-to-peer connections. So today, you guys have to go up to the server to come back down. With peer connections, you'll have to go up to a server in order to do the initial handshake and figure out where the other user is. But once you've done that initial handshake, you can connect directly to the other machine, which means much faster connections, no longer needing to deal with sort of that, hey, somebody else might shut anything down. Much better option, I think, and a much better feature.
Yeah, I think that the WebRTC stuff is really exciting, because you could already see with our experiment, you can make stuff feel pretty real time, and so you're going to be able to send so much more data back with that.
Cool. And you guys have written a case study that goes into some more technical depth on some of the stuff on how you did this, and you've got some great code examples and that in there. I've put the URL on screen for people to check out, but you can see the case study there. It's on HTML5 Rocks. I think we're down towards the end of the questions. Is there anything that you guys want to add or sort of mention before we wrap out?
I don't know. I can't really think of too much. I'm thankful for the opportunity to be a part of this.
Well, it was a great project. I think you guys did a really great job and should be very, very happy with what you got.
Cool. I think, I guess one sort of thing that I've been pondering a bit as we've wrapped it up, I think there is something about the familiarity of skee-ball that I think made this really successful in the hands of people that may not be so tech savvy and may not be, quite as hip to what's hot and new on the internet. And that's something we've been kind of talking about, just, why do people sort of latch onto it, across the internet? And I think it's due to some amount of familiarity wrapped into these sort of cutting edge technologies. So I think that's a lesson to take away, just for other sort of experimentation. Like if you can make something that may be using these new technologies that feels so cutting edge to us web developers, but make it feel not so intimidating for the average user to pick up and start interacting with. I think there's something to be said for that.
Yeah.
I think that's a good point. It's like you just have to learn one new thing. You don't have to learn 2 or 3 or whatever new things.
Yeah.
So it's a lot less intimidating.
Cool. Well, I have one last question for you guys. What's your high score?
Oh man, I got a fireball on the first turn of the game once, so
Nice.
I got like 940 or something.
All right, 940. And Justin?
All right. I guess I've played this game so many times that I don't know that I have a good answer for you. I will say, though, while we're at the Google I/O conference, we had a competition for how many hundreds we could get in a game.
Okay.
And Sean and I both tied at 2 100s per game.
All right, so just 2. So folks who are watching at home, g.co/roll it. You got to beat 2 hundreds in a row.
Oh, just in the game.
Just in the game. All right. Cool. Well, guys, Sean, Justin, thank you very much for joining us today. The URL for the documentation is there that you can go check out and have a look at the case study that these guys wrote. And thanks for joining.